Praise the Lord, everybody, and welcome back to yet another video lesson on the data structure. So this will be the final couple of video lessons, and then we'll be done with the chapter of data structures. And then perhaps in the next week, I'm just thinking of touching upon some of the exam-oriented questions based on this particular chapter of data structures. So for today's session, I would like to touch upon the final major topic, and that is the cues. But before I start with cues, I have left out, one conversion techniques in the last video. Perhaps the video was pretty lengthy, so I couldn't have it accommodated in the earlier video. So that is how to convert the postfix expression back to the infix. Even though you could do it, but I have not taught you any proper method to convert the postfix back to the infix. Let's take just one example and then we'll get on with the cues. Let's say we have this postfix expression that is to be converted to infix. So why don't you have a simple table, and then it starts with, let's say, element, the individual element in the expression, and then let's say we'll have another column called stack top, and then we'll have the final expression. Okay, so we'll start with the first element, and that will be A, and then the stack, the top of the stack obviously will be A. It's pretty simple. And then, this particular element, being the operand, it needs to be pushed onto the stack. Alright, so the A will be pushed onto the stack. So this column will scan the individual elements, and then this second column will show the element which sits on the top of the stack, and then here we'll have the diagrammatic view of the stack, and then at the end we'll be able to fetch the equivalent infix expression of this postfix expression. So move on. Now the next element that is scanned is B. So the top of the stack's element will be B, and then you will have A, and then B will be pushed onto the stack. Alright, so this arrow will indicate the top element of the stack, and then move on. Same is the case with C. On the top of the stack you will have C, and the C will have to be pushed onto the stack, and the stack will look something like this. Alright, so now comes the operator. If it's an operator, I hope you remember the rule, and the rule is based on whether the operator is unary or binary. We need to pick up the required number of the operands. Now since this is a binary operator, the next operation will be pop the two latest elements, evaluate, and then have it added back to the stack. This is something which we have learned already. So it will be like this. A will remain as it is, and then C is the first one to be popped, and then follows the B, and then you have the operator which will evaluate the expression of B plus C, and the B plus C will be pushed back to the stack. Alright, so you will have B plus C. So the result of B plus C will be pushed back onto the stack. So on the top of the stack, you have the expression of B plus C. Okay, and then you have the multiplication, right? So you have the multiplication operator. So again, since it's a binary operator, we need to pop two elements, evaluate, and then push the result back onto the stack. So this time it will be something like this. I need to pop the first element. The first element is B plus C, right? And then this needs to be multiplied by the next element, and the next element is A, right? So the resultant expression should be pushed back onto the stack. So it will look something like this. You will have A multiplied by B plus C. Alright? So on the top of the stack, you will have A multiplied by B plus C. Okay? Now, once you're finished with this, again, scan the next element. The next element will be D. Alright? So on the top of the stack, understandably, you will have the D, and then the stack will look something like this. You will have A multiplied by B plus C, and then you will have D. Alright? So we are running short of the spaces, and then we move on. Now the next, is it okay if I write here? Alright? Okay, so now the next up is, you have this as the element, and then you will have stack top, okay, and then you have the expression, alright? Okay, now the next element, that will be scanned is, after D, it's E. So I'll have E here. E will be on the top of the stack, and then this is the current status of the stack. So you will have something like this. Okay, sorry, let's make it a little bigger. Okay, you have A multiplied by B plus C. Alright, and then on the top of it, I'll have D here, and then the new incoming element being E. E will sit on the top of the D. And then you have the division operator. So you have this division operator, alright? So I'll just draw these two lines. Alright? Now the next element in line is division operator. So again, I pop E and D and then do the division. The resultant expression will be pushed back to the stack, right? So you will have E first, alright, and then division operator, and then you have D. So E will be popped first, followed by D, and then we have the operator of division, right? So it will look something like this. You have A multiplied by B plus C, and then this expression will be pushed back to the stack, okay? And then on the top of the stack, what do you have? You have D divided by E. And then finally we have the subtraction operator. Okay, you have the subtraction operator. So you have two remaining elements, the first element and then you have the second element. So pop the first element, and that is D divided by E. This is the first element to be popped, and then you have the second element. So this is the second element. The operator is minus, and then A multiplied by B plus C. Okay? This is the topmost element to be popped, followed by the next. So this expression will finally be pushed back to the stack. And then, since this operator will be the last operator, the final view of the stack will be this as a whole needs to be pushed back onto the stack. Okay, so it will be like A multiplied by B plus C minus you have D divided by E. Alright, so this is the resultant. This is the resultant or the equivalent infix expression of the original postfix. So we'll just try to have it converted back, and then we'll check if it comes out. We'll try to have it converted from the infix to postfix. So I'll just write it here, and then we'll just check. You have the A multiplied by B plus C, and then subtraction, and then D divided by E. Alright, so this is the equivalent infix of this particular postfix expression. Okay, so we'll just adopt the manual conversion technique and check whether we are able to get this. Okay, so as for the evaluation order, this should be the first one since you have the bracket. So it'll be like, you know, B, C plus, right? So this becomes the first postfix expression, and then you have D divided by E. Now the next up is you have the multiplication, and then you have the division, right? And then subtraction. So among these, the multiplication and the division, they have the same evaluation order, but whichever comes first from the left hand side, that needs to be evaluated first. I hope you remember. So this 2 needs to be multiplied. So it will be A first operand, and then second operand is B, C plus, and then followed by the multiplication operator. Okay, now the next up you have something like this. And then now you have the division operator that needs to be evaluated, and then this will be as it is. Okay, and then this D divided by E will change to D, E, and then you have slash. Okay, so these are the final 2 operands. Alright, so this being the first operand, just copy as it is. Okay, like this. And then this is the first operand. The second operand is D, E, slash, the second operand, and then in between you have the subtraction operator. There you go. So when you try to compare this and this, you know, the expression is exactly the same. Alright, so this is how you should, convert the postfix to the infix. Perhaps we could use these 3 columns: element, stack, top, and then expression. The logic is exactly the same with regard to how to evaluate the postfix expression to come up with the ultimate result. Over here, we're just trying to convert the expression from the postfix notation to infix. And then I just did this in order to ensure that this method eventually leads us to the correct answer, right? Now the next up is we now move on to the major or the main topic for today's session, and that is the cues. Okay, the main topic for today's session is on cues. Cues is similar to the stack in the sense, they both are sequence of the elements, or they are linear data structure, right? But there is a major difference when it comes to, when it comes to adding an element or on how to delete an element. Okay, so there is a big difference between the two with regard to how the elements will be added to and how the elements will be removed, from the data structure. Like I said earlier, stack and queues are nothing but the data structure. But in order to implement the stack and the queues, we use the data type of list. Of course, you could, implement the stack or the queues with the data type like the tuple or the dictionary. Okay, but here again, as it was the case in the stack, we are again going to use the list as the data type in order to explain, the data structure of queues. Right? So I'll be coming up with a big program which will explain us how the queue data structure operates. Right? But before I start with the program, let us try to understand a little bit on queues. Queue is a data structure, in which there is this technique of FIFO. Okay, F-I-F-O. F-I-F-O. Please take note. It's not FIFA, it's FIFO. First in, first out. How queue works is, a line of people, waiting at the ATM, the counter, it's nothing but a queue. Generally, a person, which comes first should be the first one out. A person who is first in the queue, should be the first one that needs to get out of the queue. So this is the technique, which the queue data structure follows. If I give you some real-life example, other real-life example, you have the single-lane vehicle entering the tunnel. Okay, single-lane vehicles entering the tunnel. The way they come out from the other end will be nothing but the FIFO. The first vehicle that gets into the tunnel on a single lane, will be the first one, to be out of at the other end of the tunnel. And then likewise, there could be many examples like the single runway, the plane takes off, the plane lands. So again, whichever lands first, will be the first one to be off the runway. Okay, so if you think properly, there could be many examples. And then coming to the examples in terms of computer operation, say you have a printer being shared by multiple computers. Okay, so each and every computer, when they send the printing commands, whichever computer sends the printing command first, that command will be executed first. So they all will be lined up in the queue. The printing commands coming from the various multiple computers that are sharing that lone printer. The printer will manage a queue of printing jobs or printing commands. So whichever computer sends the printing command first, that will be first in the queue, and that will be the first one that will be executed. So likewise, there could be another example in terms of the call centers. When people comes up with various queries, with regard to various kinds of problems. So the person who calls them the first, will be asked to hold on. Okay, the moment the service agent is free, that person will attend to your call. So whichever customers call out first, will be the first one that will be attended by the agent. So in order to understand the main principle of queues, these examples are very important. And then in various softwares, the application, the programs, queue data structure is very, very handy. So let's get on with the program. So through this program, we'll learn how to insert the element, and then how to remove the element, and then how to peek, as was the case in the stack, and then you have the situation of underflow and overflow. Okay, but since the list is a kind of data type, which could grow in size, which could dynamically shrink or grow as per the number of elements in the list, there will be no overflow situation. I need you to get this crystal clear. The list is such that it could shrink with the removal of element using the function of pop. The link could shrink. If you add a new element onto the list, it could grow in size. So since the list could grow, shrink, there are no limits to the size of the list unless and until you run out of the RAM, which is very, very highly unlikely. So overflow is a situation which is not encountered if you implement the list data type in stack or queues. But I want to give you an example with regard to C++. In C++, you have a data structure called arrays. Okay, so we could have fixed size array in C++. So fixed size array means that array could hold only 5 elements or 10 elements. We can have the limited or the fixed size array in C++. So in such data structures, if you try to add the elements beyond its capacity, those situations are called overflow. Okay, but you can have underflow situation very much in queues or stack that are implemented with the help of the list. All right, so these are the 5 important things to be noted. The first one is how to insert, how to delete, and then how to peek, how to inspect, and then you have these 2 situations of underflow and overflow. All right, so but unlike in stack, we use the term of push and pop. All right, you have the terms of push and pop in the stack, but in queues data structure, we use the term of NQ and DQ. NQ to add the element, and then DQ to remove the element. So in a queue, what happens is the elements are added at the end. When you have a line in front of the ATM, the kiosk, what happens when the new person comes in? Will he be lined up at the beginning of the queue or at the end of the queue? Understandably, he should be lining at the end of the queue. When the person leaves the queue, generally, it happens at the front. So in a queue, if this is the first person in the queue, if that is the last person in the queue, the insertion will take place at the end. Insertion in the queue will take place at the end, or you have another term for that, rear, R-E-A-R. R-E-A-R means at the back or at the end. So when the elements need to be removed from the queue, it needs to happen at the start, or you could actually call it as front. So in a queue, you have 2 ends. Unlike in stack, the insertion and the deletion, or the pushing and the popping, both takes place at the top end. But in queue, there are 2 ends, front end and the back end, or the rear end. Insertion will take place, or NQ will take place at the end, at the rear end, or at the back end, and then a DQ, happens at the front end. So, this is something which you need to take note of. So, without further ado, let's get started. I need to make a wise and a nice use of this whiteboard, otherwise I may struggle later on. So I'll just get rid of this. Okay, divide the whole thing into 3 parts. Okay, and then first things first, I need to have the menu. Okay, I need to have the main menu. So for this, before I start with the while, I should have a list called queue, an empty list called queue, and then I need the variable called front. All right, so the front will store the value of the element that needs to be removed. Okay, element that needs to be dequeued from the queue, and then we'll use another variable called rear to keep track of the slot at which the new element will be inserted, right? So I'll have the while, okay, and then while true. So this condition will always be true, and then I have menus, like you have the print. Okay, the first one is 1 dot NQ. All right, so number 1 for NQ, and then number 2 for DQ. Okay, so NQ means the adding the element, DQ means removing the element, and then number 3 is for the peek. Peek means inspecting the element, which is at the foremost front of the queue, and then 4th will be display, just to check the status of the queue, and then we'll have the 5 as leave. So to exit the program, that's it, right? So this is the main menu. This is the main menu, alright? So based on the options, we'll be carrying out the associated operation, alright? So now we'll first come up with the function definition for NQ, function call and the function definition for NQ, right? So if, I hope you're able to see this. Okay, so you have CH equals int and then input, I'll just write here choice. Okay, so you have to enter the choice first. If CH is equal to 1, if the choice entered is 1, I need to make a function call. Okay, but before I make the function call, I need to prompt the user to enter the value of item, right? So item is equal to int, you have input, and then I just write here item is equal to, alright? And then once I receive the value of item, let's call the function. The function, the name of the function will be NQ, alright? NQ, and then I send two parameters. The first one is the list, which is Q, and then followed by the item, alright? So I make the function call, and I then send the list. Initially, the Q as the list is empty, and then I along with send the item, and that item needs to be NQ'd onto the list, alright? Now we'll come up with the function definition, and then I need this, let's say, I hope you're able to see def, and then the function called is empty, just to check whether the list is empty or not. And then I'll receive it as QU, and this is nothing but a function to check whether the queue is empty or not. And then if QU is equal to, okay, this is another way to check. Whether the queue is empty or not. Okay, you have this 2 equal to sign, right? Or you could have the length of queue is equal to 0. So there are two ways to check whether the queue is empty or not. If the condition is true, then I'll return a boolean value of true. Okay, else I'll return a boolean value of false. Okay, so this is the function definition for is empty, which I'll be using in the function definitions like the DQ and then the peak. Okay, now let's come up with the function definition for NQ. So def, okay, and then you have the name of the function as NQ. Let's receive the Q as QU, and then we'll have the item parameter. Alright? Okay. So in order to add the item onto the queue, we need to use the function of append, right? So it is something like QU dot append, and then you have the item, alright? So once you append the item onto the QU, I just need to check whether this item is the first element or not. Okay, in which case I'll have to adjust the value of front and rear. Alright, so if the length of QU is equal to 0, if this condition is true, it's 1. If the length of Q is equal to 1, what it means is this element that I'm adding is the first element in the queue. If the condition is true, then I should assign front and rear both variables with a value of 0. Alright, so what does this mean is, since item being, once the item is added to the queue, and then if the length of queue is equal to 1, it means you have just one element added in the queue. If this condition is true, then the value of front and rear both should be 0. It means it'll be something like this. Let's say, this is the queue, alright? This is the queue. Let's say I add 3. If I add 3, the length of this queue is equal to 1. So which means the value of front should be 0, and the value of rear should also be 0. Hence, you will have front pointing to 0, and then you also have rear pointing to 0. If there is just one person in the queue, that person becomes the first person as well as the last person, right? So if this condition is true, then it means both the front and rear value should be assigned with 0. Alright? It's pretty simple. Okay. Now, however, else, if it's not the first element, then the rear value should be length of q minus 1. Okay, again, let's say if I have elements like 5, 6, 7, alright? And then you have the indexes like 0, 1, 2. So the value of f will be 0, understandably, and the value of rear should be 2. Okay? The value of rear should be 2. It should be pointing here. So how do you get this as the length of q is 3. You have 3 elements, 1, 2, 3. 3 minus 1 is 2. So the value of rear will always be length of q minus 1. So if the item that is added is not the first element, if it's the second, third, the value of rear will always be the length of q minus 1. So as is the case here, okay? So what should be the value of r? What should be the value of rear? The length of q, which is 3, 3 minus 1 is 2. So the value of r is equal to 2. It's quite simple, right? So this is how I actually come up with the function definition, that will, add the element onto the queue. And then, since I'm using the append, understandably the elements are added at the end. Okay, just like how people line up at the end of the queue. And then, once I'm done with this, I now go for the next one. LF is equal to 2. If the choice is equal to 2, then I am now looking for the DQ. DQ means I want to remove the element from the queue, and then it has to happen right at the front, not at the back or the rear, right? So let's call the function, and this will be DQ. The name of the function is DQ. Okay, something like this. Okay, DQ, and then I need to set the parameter of Q, right? Like this. Okay, and then if the item is equal to the underflow, okay, if the value of item, once I call the function of DQ, and then from the function definition, if underflow statement is returned onto the item, which means I'll have to print a message saying print, and then perhaps you could say it's an empty queue. All right, it's an empty queue. Else, your message should be print, and then the front most element is, okay, so when you remove it, it has to happen from the front. So the frontmost element will be the item, okay, something like this. Now this should be the part of the the main part of the function, main part of the program. Alright, now let's come up with the function definition for the DQ. Alright, so we'll have this DEF, and then the name of the function will be DQ, and then we'll receive just the Q. Okay, we don't need the item as such, since we are removing. Alright, so again, in order to remove, I need to use the function of pop. But if you just use the pop function, it will pick up the last element of the list. So you need to watch out. But the thing about Q is we need to pop the element from the front. So which means, first I check whether the queue is empty or not. If it's empty, then you have a situation of underflow. Alright, so I'll just I have this lines in order to break them logically. Okay, now the next step is I just check. How do you check is if is empty, let's call the function of is empty, and then I send QU. Alright, so I call up this function, and then based on this condition, either true or false will be returned. If the stack is empty, true will replace this function call. Okay, so if it's true, then I would like to return a statement or a message of underflow. Alright, okay, like this. And then else, if the stack is not empty, then I need to pop the first element. How do you pop the first element is I have here item is equal to the name of the queue list is q dot pop, this is small p, and then you need to write here the index. Now this is important. You are trying to pop the element with the index of 0 from the list called q. If I repeat it, this function will remove the element which sits on the index number 0. Index number 0 always points to the first element in the list, and then it's assigned to the item. Okay, so but there could be a situation like if you have just one element in the list. Let's say I call upon the DQ, I reach here, say you have only one element, I pop that element. Now the stack is empty, the queue is empty. If the queue is empty, I need to change the value of front and rear to none. Now since there are no elements left in the queue, the value of front and the rear need to be adjusted to the none. Since there is no element left in the queue. So why don't you check? How do you check this is if perhaps you could just write it here. Okay, if the length of if the length of Q is equal to 0. Okay, now let's say, like I said, if there is just one element left and that's popped off, the condition will be true. If the condition is true, then what happens here is the front and the rear both values should be changed to none. Alright, so this is how the queue should be. Since there are no elements left, the front and rear value should be set to none. Alright, and then once you are done with this, finally I need to return the value of item. Right, so I just write here return item. Right, so it's pretty simple. Call the function of DQ. If it's empty, return underflow. Okay, if there is just one element left, that element will be popped off. The condition will be true. The front and rear value should be changed to none. So you have an empty queue. So the front and rear, understandably, should be none. And then at the end, the value of item, should be returned back to the function call. Right? So this is how you come up with the function definition for DQ. Now let's move on with the next one. You have LF CH is equal to 3. If the choice is equal to 3, then we want to have a look at the frontmost element. Alright, the frontmost element. Alright, so again, this whole thing will be similar to this. This whole thing could be copied onto this part. So I'll just okay, no problem. I'll have it written item, and this time I'll have peak and then send the Q. Alright, and then again, if the returned item value is equal to underflow, okay, if the condition is true, then you should print the message of print empty Q. Okay, like this. Oops. Okay, no problem. And then you have else print the frontmost element S, and then you have the item. All right. Okay. So this is the statements for the peak. Now let's come up with the function definition for the peak. So you will have def and then peak. Let's receive it in Q. All right. So this is pretty simple and straightforward. First of all, I need to check whether the Q is empty or not. All right. So let's call the function of is empty, and then I sent the Q. Okay. If the condition is true, what happens? You have the return. Okay, underflow. If there are no elements in the queue, I need to pass on the statement of underflow. If it matches, then I'll get the message of empty queue. And then otherwise, if it's not, then okay, the value of, why don't you set the value of front is equal to 0, and then return the first element in the queue. Okay, how do you do this? Return the name of the list is Q, and then you have here front. Okay, so this is again another way to just inspect the element which sits first in the queue, right? So front is equal to 0, and then return Q. Front. Q of 0 means you're obviously referring to the first element of the queue. So once you return it, either the item will have the value of underflow, or if the queue is empty, or it will have the value of elements, the value of the first element in the queue. The condition will be false, and then the item value will be printed. Which is nothing but the value which is being returned by this particular statement, right? So this is how you come up with the function definition of peak. It's pretty simple. Now finally, it's time to display the status of the queue, right? So that would be choice number 4. And then you have LF choice is equal to 4, okay? If the choice is equal to 4, then call the function called display, and then you need to send the queue list, right? Send, and then we'll now come up with the function definition for queue. So it's going to be like this. I'm running short of spaces. You have def, and then the name of the function is display, okay? And then you have QU. Alright, so again, first things first, I need to check whether the queue is empty or not. Okay, if it's empty, how do you check is if the length of queue is equal to 0, then print a message saying It's an empty queue, alright? Okay, however, if the length of queue is equal to 1, if there is just one element in the list of queue, then the front and the rear, both variables should be pointing to that lone, that the only element in the queue list, right? So how do you print it is, I think it's pretty, straightforward. Print, okay, and then the name of the list is queue, okay, and then you have 0, okay, and then followed by, perhaps you can have something like this, okay, greater sign equal to less than sign, and then write front, and then comma, and then write rear, alright? So just in case if there is only one element in the list of queue, that element will be printed. Queue of 0 understandably points to the first element, and then you will print this particular message indicating that front and the rear, both variables are pointing to that lone element, the only element in the queue. So this needs to be done if this condition is true. However, okay, else, if it's not empty, if it just doesn't contain only one, then what happens? Then the way the queue needs to be printed is slightly different. Okay, so I'll just get rid of this. It's a little different. Okay, so, and then first things first, I have the front value set to 0, and then rear value set to, how do you get the rear value? Remember, it has to be length of queue, okay, length of queue, and then minus 1. So once you get the front value, rear value, then you need to print the front element first, so you could actually print it as queue, and then you have front, alright, and then followed by, I'll just have a message of front, okay, like this. So the first element will be printed, assigned to it is a front label, pointing to the queue of 0, which means this is the element which is at the frontmost end of the queue, and then I now need to print the in between the elements between the front and the rear end. All right. So for this, I'll run a loop for a in range, right, and then I'll write 1. I need to start from 1 because the 0 is, for the first element. So the first element has been printed already because I need to have this label next to the first element. Hence I had to do this before the loop starts. Alright? So the value of A now should start from 1. Okay? So 1, and then it needs to move on till the value of rear. Okay? Like this. Alright? And then after this, I come up with the print message. I need to now print the in between the elements one by one. So print, and then you have Q, okay, and then I just write here A, right? So the first value of A will be 1. So Q of 1 means the second element in the list. So this will go on till the rear, but the rear will not be included. It will be excluded, right? So at the end, once I manage to print all the in between the elements, and then at the end, I'm now left with the last element in the queue. So that needs to be printed, right? So at the end, I have print here. And then you have the queue of the rear itself, okay, comma, and then I'll have a message saying this indeed is the real element, the element which is at the last. All right. So you have something like this. So the first element will be printed, which will have the message of front, indicating that this element is at the front foremost end of the at the beginning of the list, and then in between elements, and then finally the real element itself. So this is how you write a program for the queue. All right. So we'll now run the program and check how will the output be. All right. So even though we are running out of spaces, we'll just try. We'll use this perhaps. Okay, we'll just use this. Okay, I start with number 1. The while loop runs. Okay, and then it starts with this particular statement. Let's say I enter choice number 1. All right. I hope you're able to see. I enter the value of choice as number 1. And then what happens is I'm, being asked to enter the value of the item. Let's say, I have 6 here. All right. I enter 6 here. And then what happens is the queue and the item will be passed on to this particular function definition. Right. So in the queue, I'll be appending the 6. So you have 6, something like this. Let's say, this is the queue, all right? So the 6 is being added, all right? And then again, I enter the next value of item as 7, okay? 8, 9, 10. So every time, I append, it will look something like this. The 6, 7, 6, 7, 8, and then you have 9. Let's say I, add 5 elements in the list of queue. So they all will be added at the end. Okay, new value comes in, it will be added at the end. Now let's say I would like to go for choice number 2. When I go for choice number 2, what happens is, this DQ function is called upon. This function will be called upon. This particular function will be called upon, and then it checks whether it's empty or not. If it's not empty, look at this statement queue. This is nothing but a queue. The first element will be popped using the index of 0. So this is 0, and then 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. This is 4, right? So the first element will be removed from the queue. All right. So which means queue dot pop 0 means this will disappear. All right. So this will disappear. Okay, 6 will disappear, and then it checks whether the length of queue is equal to 0 or not. Which is not the case. So that particular 6 value will be returned. And then it will be received in item which is not equal to underflow. The foremost element is the 6. So as you can see, with each append, the elements will be added at the end. With each, the DQ, the element that will disappear from the queue will start from the beginning. So this will go on and on, right? Now let's say, I want to check. I want to inspect the frontmost element. That's the definition of peak. All right. So you have peak here. Call the function. Check whether it's empty or not, and then front is equal to 0. Look at this. The value of front should be set to 0. All right. So return queue front. Now this time what happens is, in the list itself, will be adjusted automatically such that this will be 0, this will be 1, this will be 2, and this will be 3. Okay, so this is what happens with the pop. When you execute this pop, automatically, or dynamically, like I said at the beginning, the list the shrinks or the links the list, the group. So automatically you will have the numbers lined up like this. So front is equal to 0, Q of front, Q of 0 is being returned. Be mindful of this, I'm not popping, hence this 7 will not be removed from the queue. Rather, it's just being returned. We're just inspecting, we're just taking a peek or look at the frontmost element. With this, what happens? It just removes the element from the queue. So, and then the foremost element is item. Okay, and then let's say I want to display this. Now let's say this is the latest 7, 8, 9, 10 is the latest status of the queue. All right. So how will this be printed? Okay, how will this be printed? I better make use of this, please. All right. Let's say you have 7, 8, 9, and then you have 10. All right. 0, 1, 2, 3. Okay. So let's say I would like to display the content of queue. And then I call upon the function of display. Where is it? It's here. Check if the length of queue is equal to 0, which is not. The length of queue is equal to 1. It's not true as well. Okay. And then else. We now, focus on the third part of the display function, right? So the value of front is equal to 0. The value of rear, the length of queue is how much? 1, 2, 3, 4. 4 minus 1 is 3. So you have front value as 0 and rear value as 3. Alright? Print Q of front. Print Q of 0. Print Q of 0 means Q of 0 means you're talking about the first element, right? So Q of front means Q of 0. So I'll just have the first value printed as 7. Okay, and then just next to it I'll have this the front. Okay, and then I now go for the for loop. A in range 1 comma the value of rear is how much? It's 3. Okay, this is 3. So the value of A will start from 1. The value of A will start from 1. Q of 1 means you're referring to 8. So this 8 will be printed. And then it goes for the next value of A. The next value of A is 2. Q of 2 means, you're pointing to the 9. So the 9 will be printed like this. So when the value of A becomes 3, 3 doesn't fall in the range of 1, 2, 3. Hence you leave the loop. You come out of the loop. And then finally, the value of rear itself is 3. Okay, so Q of 3 means you're pointing to 10. So you will have something like this, and then just next to it, I'll have the rear. Alright, so this will be the final output, of the display function. So with each NQ, what happens is the element will be added at the end. Alright, and then with each DQ call, the element will be removed from the front end. So this, has to go on and on. All right. It's a must that you have to run it on the system. Okay, because even if you understand the program fully, but if you do not run it on the system, it's little, it's little, kind of a missing puzzle. Okay, so just try to run it on the system if it's possible. Otherwise, if you could understand the program, that should be enough, right? So regardless of the choices that you make, accordingly you perform the NQ, DQ, display. The status will keep on changing. So generally, it should be like this. You perform NQ, say number 1. And then enter the value of item, and then check the status of the queue. Okay, and then again, another NQ followed by the display function call. And then if you want to perform the DQ, so in between NQ and DQ, if you could time and again call the function of display, you'll be able to understand better. All right. So this is all about queue. Now we'll move on to the next part. That is, okay, so at the end of the program, you should be imagining Q like this. Now let's say, you have, the series of NQ and DQ, all right? Say Q, is empty at the start, all right? Q is empty at the start, and then it will look something like this. Okay, it's completely empty, and then you have front and rear, both values should be none. Okay, so this should be the initial status of the Q. All right, the front and rear value should be none. Now let's say I come up with the first step of NQ, and then let's say I write a character called A, and then the status of the Q will be something like this. A will now be added onto the Q, and then you have the front and rear, both pointing to the first element. So which means the value of front and rear will be 0. Okay, so the index of the first element is 0. And then let's say number 2, say I NQ a character of B. So again, it's simple and straightforward. You have A already, now the B will be added at the end. This is how the Q works. Now this time, front value will be 0, or it will be pointing to the first element, and then the rear will be pointing to the character of B. So the front value will be 0, okay, and the value of rear will be 1. You have indexes like 0 and 1. Okay, let's NQ one more. Say NQ of C. All right. Again, what happens here is A, B, and C will be lined up, and then you have again front pointing to the first character, and the rear will now point to the character of C. And the value of front being 0, the value of rear will be changed to, it'll be 2. So this is how the front and the rear value gets adjusted. Now let's say I want to DQ. Okay, I want to DQ, an element, from the list of Q. Then what happens is, the deletion or the removal will take place at the front end. So the new look of the status will be something like this. You will now have B, and then you have C. The front will now be pointing to B, and the rear will point again to the C. So the value of front will be, this is 1 and this is 2, right? So the value of front will be 1 and the value of rear will still remain as 2. So this is how the front value and the rear value keep on changing with each NQ, with each DQ. Either the value of front will change or the value of rear will change. But there is one very important thing to be noted. Some of you may feel that, the front value is changing, from 0 to 1, 1 to 2, and then how come, the program or display, always starts with the index of 0. This is just, the diagrammatic view of how the Q operates. Okay, but in programming terms, when you actually carry out, the real operation, like I said, the list is very dynamic in nature. As and when one element, gets popped off, automatically it shrinks. Now this is important. Okay, if you add another, it grows. If you remove, an element from the beginning position, it shrinks in size. Okay, so it's so dynamic in nature that the list, it could either shrink or it could grow. Whatever said and done, the first element in the list will always be represented by the 0. Okay, the 0, the index value of 0. This is the reason why prior to the printing of the elements in the queue, we had set the front value to 0 and rear value is equal to length of q minus 1, right? So, this is just a diagrammatic view of how, the queue will look like with each, step of either NQ or DQ. Now, if you just continue, with the DQ, then, you have a situation of underflow, right? Like I said earlier, since, the list could grow, there cannot be a situation of overflow unless and until, the RAM runs out, okay? Now, finally, you have some variations of the queue, which is pretty simple. And then as per your syllabus, we don't have the implementation of these variations of queues. All you need to know is the introduction to the variations or the types of this queue. The first one is the circular queue. You just need to know what exactly it is. Circular queue, okay? Now, like I said earlier, what happens is, okay, let's say I have A, B, C, D, and E, right? Now, this is little to do with the programming languages like C and C++. It should not be a problem in the Python programming language, especially, since we're using the list to implement, the queue. Let's say you have a queue like this. When I DQ, A disappears, B disappears, alright? Now the problem here is I cannot use the earlier unutilized spaces, right? So this used to be a problem in the queue in languages like C and C++, okay? You just need to know what the situation is first. With each DQ, what happens is the first element, second element disappears. It leaves a space behind. Now the question is, if I want to use this, I cannot do so. If I want to add the elements, if I want to use this unutilized spaces, can I do it? I cannot do it because the insertion, takes place at the end, not in the beginning. So you will have, the unutilized spaces which go to waste. All right. In the case of the linear queue. In the case of linear queue, this used to be the problem, okay? I'm talking about the C and the C++. But the queues of Python will never be a problem, remember? Because it could grow infinitely. It could just grow, until and unless the RAM runs out. It's a little tricky, but you have to imagine that, if we have a queue in C or C++, which is bounded in nature, which has fixed number of elements. The problem with the linear queue is you will end up wasting the spaces which are in the front of the queue because you cannot add elements, from the front end, right? So in order to prevent the wastage of utilized spaces, we have the variation of circular queue in the earlier programming languages. So if you could make this in a circular shape, something like this, let's say like this, okay, and then you have various partitions like this, okay. Let's say you have A, B, C, D, and E. So somehow if we could, make the shape into circular, then what happens is, say I get rid of this, alright, I get rid of this, now this is unutilized, I get rid of this, this is unutilized, alright, but I could add the new elements here, okay? I could go on adding the new elements like F, G, H, and then I, J. It looks like as if I'm adding the elements at the end, at the rear end. And then the benefit is, in the process, I am able to use the unutilized spaces, with the DQ operation, okay? So, I hope you're able to understand this. So the problem with the linear list is, with DQs, I cannot add elements in the utilized spaces. The reason is the insertion can take place only at the end. But somehow if I can make the linear queue into circular queue, what happens here is, let's say, initially it's something like this: A, B, C, D, and E. Alright? And then, let's say I get rid of this, okay, but I could go on with the insertion at the end, okay? But even though it looks like I'm adding the elements at the end, in the process I'm able to use the unutilized spaces because of the earlier sets of the DQ operation. So this is called circular queue. And then you have another variation called DQ. It is just DQ. Don't be confused, this DQ with this DQ. Alright? This DQ means removing the elements from the queue, and that has to take place from the front end. This DQ means double-ended queue. Double, okay, this D stands for double, and then E stands for ended queue. Alright? And this particular variation, what happens is, you can have insertion as well as deletion at both the ends of the queue. As of your curriculum, you don't really need to understand how this operation takes place. All you need to know is just the basic or the overview of what circular queue is and what DQ is. So in double-ended queue, as the name suggests, the insertion and the deletion can take place at both ends. Again, there are two types. The first one is input restricted. Okay? Input restricted. And the second one is output restricted. Alright? So in the input restricted, what happens is, let's say I have the queue like this: A, B, C, D. Alright? So input restricted means you can add element. You can add element only at the end. Input restricted. So logically it means I can add element only at the end. However, I can delete the elements from both ends of the queue. Okay, so input restricted means the input will, take place only at the end, as is the case with the queue. But, when it comes to deletions, could take place at both ends. So that's the reason why we actually call it as double-ended. And then in output restricted, what happens is, okay, let's say again you have A, B, C, D. So I'll just write something like this. Okay, the deletion could take place at both ends. In output restricted, what happens is you can do the removal, from only at one end. So the removing generally takes place at the front end. Okay, so output restricted means the removal can take place only at the front end. However, the adding of the element, could take place at both ends. So you need to be a little, logical. Input restricted means you can only add at one end, that is the rear end, but you can have the removal or the deletion at both the ends. And then in the output restricted, you can remove from both ends, but however, in output restricted, you can have the element removed only from the front end, but you can have the insertion at both ends, right? So you just need to know the basics on circular queue and DQ. How it's implemented, is not a part of your syllabus, but I just want to focus a little bit on the circular queue. Circular queue is never a problem in the Python programming language, because the queue is implemented in the form of list. Like I said, list grows and shrinks dynamically. if this linear queue is implemented using arrays in C or C++, which could have a fixed size, which could have a limited or a bounded capacity, that's when the linear queue comes up with the problem of unutilized spaces. So in order to prevent these unutilized spaces from going to waste, you have this variation of circular queue. All right. So with this, I would like to end up my today's lesson. I hope you have understood. Okay. So and then, like I said, in the next video lesson, I'll be covering some of the exam-oriented questions. Until then, take care and study hard. Thank you.